From Uncovering Chemistry. Today in video 14 of unit 7, that is P block element, we are going to discuss about properties of sulfuric acid. Right? Now in that there are two types of properties, physical properties and what we call it as chemical property. First we will discuss about physical properties. Okay, just a minute. Now when we talk about physical properties, what we say here in this case, it is point number 1. It is colorless, oily liquid with specific gravity. So when we talk about this, that is specific gravity, from that also you can find the what you call purity. That is specific gravity of colorless liquid with high density, very thick it is, and specific gravity, what we call of 1.84, specific gravity of 1.84 at, you can see that at 298 Kelvin. Understood? At this temperature the specific gravity is 1. I think you can watch. Okay, 298 Kelvin. Now the second, what you call the physical properties, it freezes at 283 Kelvin. It freezes at 283 Kelvin. Understood? So it freezes at 283 Kelvin and boils at 611 Kelvin. So its boiling point is very high. What we say? Then what we call about the third physical properties, its dissolution, means what? Mixing in water is highly exothermic. Means what? Its dissolution. So when you mix dissolution in water, is highly exothermic. So you have to be very careful when you add sulfuric acid to water. You have to add sulfuric acid to water, not water to sulfuric acid, otherwise you will burn yourself. Okay. So sulfuric acid, when you have to add very slowly, pour it with a small amount, and constant stirring is required when you add acid to water. So its dissolution in water is highly exothermic, therefore it should be it should be diluted carefully. Understood? So you have to be very careful while adding sulfuric acid to water. Now we will discuss about its chemical properties. Which properties? Chemical properties. You can write down this in your fair book, physical properties, because it is there in your what you call it as board exam. And a maximum MCQs can be asked from this, what we say. Okay. Now we will talk about chemical properties. So here the chemical property we can start, that is, it is a strong acid with low volatility. It is a strong acid with low volatility. It's a strong acid with low volatility, what we say. Then second number, it has strong affinity for water. What is it? It has strong affinity with or for, what we call it, a strong affinity with or for water. I like, with will not be a good word, for water. Okay, means it mixes with water very fast, so you have to be careful what you do. Then what we call it as, it can act as an oxidizing agent. What? It can act as a oxidizing agent. Clear? Means it shall get reduced, what we say. So it can act as an oxidizing agent, what we say. Then it ionizes in following two steps. I think this you must be knowing. It ionizes in following two steps when it is mixed with water. Okay. So when we say the step 1, in which one hydrogen will be liberated, and in step 2 another hydrogen So when we write like this, that is H2SO4 plus H2O gives you what? H3O plus HSO4 minus. Now in this Ka1 is greater than 10, what we call, right? Then in the second step, that is HSO4 minus plus H2O will give you what? H3O plus SO4 2 minus, that is Ka2. When we say Ka2 value, that is acid dissociation constant, what we call, and this is Ka1 and this is acid dissociation constant 2. When another what we call hydrogen is liberated is 1.2 into 10 raised to minus, I think minus 2 it will be, minus 2. Okay, so this is Ka1 and Ka2 value, and the large value of Ka1 means it is largely dissociated in H plus and HSO4 minus. This is the highest value, what we call. Understood? And we know as the Ka value is more, it is more acidic in nature, strong acid, what we call. This is the reason what we say, that is first dissociation constant, what we call. Okay, now due to presence of two ionizable hydrogen, it can form two types of salt. I think in your textbook it is given on just a minute, it is given on page number 196. That is I will write down this, you can just drop this part, so it will be easier for you. Okay. Now, when we talk about this part, that is another property, that is due to presence of two ionizable hydrogen. A, B, C, D, E. Next point, due to presence of two ionizable hydrogen. Due to presence of two ionizable hydrogen, what we call, it can form two types of salt. It can form two types of salt. Clear? I think you must have heard about the word salt. So it forms two types of salt, that is a normal salt, what we call it as normal salt. Okay, and the next one, what we call it as acid salt. Which salt? Acid salt. Now, when we talk about salt, we know the formula, that is acid plus base will give salt plus water, what we studied. Okay, so this is the salt what I am talking about. So when it forms normal salt, it will give you what? Na2SO4, CuSO4. These are the normal salts when it form with a base. Understood? Means suppose if I use here acid H2SO4 and base if I use NaOH, what I will get? Then I will get Na2SO4 plus H2O. That this is the normal salt what it is formed. Okay. Then the another acid salts when we say it is NaHSO4. Understood? This is the acid salt what it forms. That is with the metal hydrogen sulfate what we call. Understood? So these are the acid salts what we form. Okay, so this is all about what we call it as the salt formation. Then another one example is there when it reacts with the MX type. So that we are going to discuss. It reacts with MX type of salt. What is the word? It reacts. This is another point. It reacts with, this all comes in complete the reaction. It reacts with the MX type of salt. Clear? Now when we say X is equal to fluorine, chlorine, bromine, iodine, like this what we say. Understood? So when it reacts with, fluorine, chlorine and NO3. NO3. X we can take this as like this what we say. So when it reacts with the MX type of salt to produce HX acid what we say. MX type of salt to produce HX type of acid. Clear? Now when we see here MX, here MX means M is equal to metal what we say. Understood? Now for this one nice general reaction is given in your book, that is MX plus H2SO4 gives you what? HX. What does it give? MX plus H2SO4 gives you what? HX plus what you call it as M2SO4. Understood this part here? So you can balance it later on. So we write here 2mx, here 2hx like this. Is it clear? So suppose metal, that is Cl2, what we say, H2SO4 gives you what? HCl plus what we say, Ca2SO4 or CaSO4 it will form. If I take calcium here, instead of, if I take KCl, like this, if I take KCl, then it will be what? Here HCl, and here it will be K2SO4. Like this, I think it will be easier for you to understand. Okay, like this. Balance. Okay, so this is the type. You can write down this because here this is just a general form what is given. Okay, so in this case, that is MX2 it reacts like this. Okay, since it has a great attraction for water, it can be used. Now, this is another point. Since it has affinity, what word we say? No, means attraction. Since it has great attraction to water, it can be used. It can be used as an it can be used as dehydrating agent. Now, what is dehydrating agent? It is used to remove water from the reaction. Okay, it can be used as a dehydrating agent. Okay, many wet gases can be dried with concentrated H2SO4. Understood? Now, sulfuric acid can remove water from organic compounds. That is, I think it is given in your book. It can remove organic compound. Now, this I will just take it as another point. Sulfuric acid can remove water from organic compounds. Clear? Now, from organic compounds, when we say in your book, they have nice given an example of sugar, charring of sugar. What is the word? Charring of sugar. Sugar means C12H22 and O11. If I use here concentrated H2SO4, what is the word? Concentrated H2SO4. From this, water molecule will be removed. What will be removed? Water molecule, that is 12 carbon plus 11 H2O will be formed. Understood this part? So this is the removal of water molecule when you use, because it has great affinity. Remove water from organic compound, means from sugar. If you want to remove water, if you mix sulfuric acid, the sugar will turn into black color. That is carbon, what we say, 12 carbon. Means charring of sugar it is called. It is also used for caramelizing the cake. You remember, you heat sugar in a pan, frying pan, it will turn brown color. That is due to loss of water. So same thing, it shows this reaction also as a dehydrating agent. Okay, so it can remove water from what we call it as organic compounds also. Now, okay. When it is hot, it can act as an oxidizing agent. So that is the new point which I can write in this chemical properties. Okay. When it is hot, another point I can write. When it is hot, it can act as an oxidizing agent. Clear? So this one, what is written, that is when it is hot, it can act as an oxidizing agent. That is itself, it is reduced. Itself, it is reduced to SO2. Understood? So it itself get reduced to what we call it as SO2. Okay, means it is less oxidizing than. It is less oxidizing. That is H2SO less oxidizing than what we call it as HNO3. Means HNO3 is a strong oxidizing agent. What we call. Understood? HNO3 and more oxidizing than. So this one, see, remember this thing, this one is asked for MCQ. It is less oxidizing than HNO3 and more oxidizing than H3PO4, phosphoric acid, what we say. Understood? So remember this part. Now this we have already discussed in what we call H3PO4 in oxoacids of phosphorus, if you remember. Okay. Now oxidizing power, if you want to write, oxidizing power. Oxidizing power, if you want to write the order, oxidizing power. If you want to write the order, you can write like this: HNO3 greater than H2SO4 greater than H3PO. Remember this thing, what we say. So this is the strongest oxidizing agent, and this is the weakest. Okay, so don't forget this part what I am talking about. Understood? Now it can oxidize metals as well as non-metals. Okay, it can oxidize metal as well as non-metal. Right? Now for metal, when we write the reaction. For metal, when we write the reaction, metal as well as non-metal. So for metal, the reaction is Cu plus H2SO4 gives you what? CuSO4 plus H2O. What we say? Plus SO2. Okay, I think it is balanced. Here it will 2 will come. Understood? So this is concentrated. This sulfuric acid is concentrated. Okay, so reaction of metal with this is metal plus acid and gives salt plus hydrogen gas actually, but in this case it forms water. Understood? So this is a general reaction what you can remember in this case. Then what we call it as next with the non-metal. With what? Non-metal. So for non-metal there are 2 reactions what we say. Understood? Reaction number 1, sulfur S plus H2SO4. This is one reaction what we say. Then carbon C plus H2SO4. This is another with a non-metal. Okay? So sulfur plus H2SO4 and carbon plus H2SO4 will give you what here? 3SO2 plus H2O, that is sulfur. Sulfur dioxide, it gives plus water. In the second case, CO2 plus SO2 plus H2O, like this with carbon. So in this case it is not balanced, so I can write here 2. Over. So this is all what we are seeing about the properties of what we call it as sulfuric acid, that is physical and chemical properties. Okay. Now in this video only we will continue with the uses also. You can see the uses of sulfuric acid. And just rub this part. Okay. Chemical properties, I think it is over. Now we are going to discuss about uses of sulfuric acid. Clear? Now when we talk about uses of sulfuric acid, first in manufacturing of fertilizer. This is the most abundant use what we call it. It is also called king of chemical. It is used in manufacturing of fertilizer. Example, what we call it as ammonium sulfate. Ammonium, that is NH4 twice SO4. Ammonium sulfate. Then what we call it as superphosphate. I think this we already studied in phosphate of lime. What we call superphosphate of lime, ammonium sulfate. Okay, then it is also useful in petroleum refining. It is also useful in petroleum refining. Okay, then it is used for petroleum, is used in manufacturing of paints. Manufacturing of paints, pigments, I think dyes, what we say. Paint, it is used in manufacturing paints, pigments and dye. Dye is what we say, pigments. It is used in manufacturing of paints, pigments and dyes intermediate. Okay. Then when we talk about the fourth point, what we say, it is used in leads to detergent industry also. It is used detergent industry, then in metallurgy, where purification of metal is carried out. So it is used in detergent industry, then metallurgy to clean metal before enameling, then electroplating, metallurgy, then electroplating, clear, galvanizing, clear, zinc, what is like this, okay. Then what we say, the point number 5. It is used, what we say, then it is used in lead storage battery. If you have heard about our batteries, what we use in car. So it is used in lead storage battery. That is rechargeable batteries, what is for cars, bikes, and all, what you say. So that is, it is used in what you call it as lead storage battery and other storage battery also. It is used in manufacturing of nitrocellulose. Clear? It is used in manufacturing nitrocellulose, and also if you don't know any point, you can write as it is used as laboratory reagent. Okay, this is the best you can remember. It is used as a laboratory reagent. So this was all about uses. Then chemical properties, that is physical and chemical properties. Okay. So this was all about sulfuric acid. Okay. Now in the next video, we will be discussing about group 17 elements. Which elements? Group 17. So whatever things we have written, please write it down in your fair book. It will be helpful to you. Okay. Thank you very much.